But I think also, Keith and Morgan, some of these questions are probably stuff that you're going to address and talk about in your fireside chat as well. So I don't want to steal any of your thunder away. We will take ourselves backstage. Can you just give us a quick sound check so we can make sure we can hear you?
Testing.
Got it?
Hey there.
Perfect. Then y'all can take it from here.
Shall we bring your slides to the screen too?
Oh, I think I can share my
slides.
I made like 3 slides. I wasn't totally sure we were questions.
Do you have a virtual fire for us in the background too?
Oh, that would be great. That would be
really cool. You should have gotten a Yule log together and just like cozy vibes. That would have been great.
Wait, what if we put a comma? What if it was a fire, comma, side chat?
We'll leave them off, but if you want them on, just let us know and we'll pop them
on. Okay, let me see about sharing my screen here.
We can just do they can just upload the slides directly if we want to, without having to share the entire screen if you want.
Sure. There's just a couple of things that we may show.
All right, go ahead.
Okay. All right. So we had a very provocative title. These are old slides. These are the old slides. Let me share my screen. That'll be better. We had a very provocative title, and there we go. Can we see that?
Waiting.
Yes, there we go.
There we go.
Beautiful. Oh, look at that. So,
all right.
Yes, our title is very provocative. It says what we don't talk about. So I'll try to live up to that. In the last chat, I noticed that there was mention of Spiffy, which is great. That's a standard we can use to give a nice global ID to agents, which is one of the things that we'll touch on today. But I guess I should introduce myself first before I go into that. My name is Morgan Foster. I work at Red Hat in emerging technologies, which means I spend a lot of time thinking about the future, but I work a lot with IBM research, and I'm trying to connect what's in our research pipeline up with what's being developed into real working engineering practice for the folks that work with us at Red Hat. But aside from that, I work with Keith as a co-chair on the Kubernetes AI Gateway Working Group, where we are coming up with standards which define a control plane for an AI gateway, which is a gateway that speaks AI protocols. And that's actually pretty challenging, which is another thing we'll chat about today. Keith?
Yeah, absolutely. I'm Keith Maddox. I work at Microsoft doing service mesh and networking things. I'm a core maintainer of the Istio project. And as Morgan said, I work with her and some other lovely people on AI Gateway to codify a lot of the things that we've seen in the industry since, November of 2022, and try to help our infrastructure catch up to this new technology that has been such a big part of everybody's lives. And hopefully we'll get into a lot of the details of what that looks like here in this chat.
Maybe there's a lot to cover.
We're gonna do our best.
So the first thing that I want to say is that we talk a lot about identity, absolutely, in the context of agents. But I think what we don't talk about is that we don't really have a robust way of enforcing this identity, using this identity, threading this identity through our infrastructure. And what do I mean by that? I'm going to pick on VS Code real quick. I don't know what happened under the hood here, but I do know I work with agent platforms every day. And one of the problems that we consistently see are problems with keeping track of complicated chains of delegation. So if you have an agent that creates a sub-agent, how do you create a relationship between those two agents that maintains a separate identity for both? And I think this billing issue is an example of the sort of problem that can pop up whenever we can't do this robustly. Essentially what happened was there was a free tier that you could use you had your, your coding assistant, and then it could spin up subagents, which is super useful. But the subagents can have a different model than the parent agent. Different models have a different cost basis. So because that identity was not being tracked cleanly, I'm guessing, the subagent was charged at the free tier while the it was actually using a relatively expensive model under the hood, I guess Opus 4.5 at the time. So VS Code obviously fixed this, but this is another example of a whole class of problems. I would say this fits within this class broadly, which is this sort of confused deputy. This class of problems called the confused deputy problem. And the TLDR is we cannot rely on a static configuration based on a well-known set of possible paths through our infrastructure to enforce policies. And this is a real change in our mindset. We also can't rely just on something like MTLS, because we need to track not just who someone is, who they say they are in the moment, but we need to track long chains of delegation and make decisions about and apply policy to the interactions between these actors in our system. And the reason I say we don't talk about how hard that really is because this, even if you have token exchange, even if you have Spiffy and Spire, it's expensive to track this delegation through our infrastructure. So that's kind of what I wanted to talk about is with Keith is how we can make it possible to do something like pass a JWT through our infrastructure, exchange. Ideally, you would exchange that JWT with your secure token service between every hop, and it would add some sort of audit trail via what's called an ACT claim to the JWT. But that's incredibly expensive. And so I don't see it being deployed, that pattern being deployed widely, even though it's probably the best solution here.
Yeah, I think you're absolutely right. You know, when I look back at the ecosystem and how we have thought about identity to this point, and I've been working in networks for a while, the way that we tend to make these assumptions is that there are two types of identity. There is machine identity, which are bound to workloads, pods that spin up in a Kubernetes cluster, container instances in your cloud service. There are these short-lived credentials that are bound to the lifetime of the workload. And separate from machine identity, you also had user identity or human identity. That's usually encoded in a JWT. A gateway often would be the thing that validates the JWT, propagates claims and headers or something like that. And we really had two different flows with two different sets of assumptions because there are two different types of identity. Agents flips that on its head. Now your IDP, your identity provider, has to be able to give your agent a durable, verifiable identity that gets propagated throughout your system. And Morgan, as you were saying, we need to not only know, what workload that agent is running on, what access can it access this bucket, can it access this cloud service, can it access all this sort of stuff. We also need context on who was the original human being that initiated this request, not just for the initial agent spinning up, but also any sub agents that get spun up. We need to keep that context all the way throughout the system. And this is challenging to do on the wire. If your IDP is constantly giving you doing token exchange, yes, it might be able to do that, but the scale is going to impact you. The actual bandwidth that gets taken up just by ACT claims is going to really add up as you propagate and delegate throughout the system. So, how do we approach this? What do we do? Things that come to mind, you mentioned that RFC with ACT claims, that I think is a great step in the right direction. I think, ultimately we're going to get into a little bit of a second. But ultimately, I think when it comes to identity, we're having to rethink what the gateway does, what the identity tells us. It's not just what access the thing is allowed to do now, but what access might it need in the future based on the prompt? What might it, what other models might it call? All things of that nature. So the primitives that we've got at the gateway layer really are having to evolve to be able to be sufficient for this AI use case just to do the bare minimum. And that's challenging for proxies and gateway implementations that have been around for decades or longer.
Yeah, definitely. And I'm thinking about a pattern that I think we're seeing, Keith, is that we're having to violate some of the principles that I think we held dear in the past. And one of those is the idea of sort of keeping things separated as much as possible, separating our concerns. I'm not saying that we shouldn't keep separating concerns, but because it's heavy, because it's expensive to do something like add an extra hop between every request where you're talking to some identity provider and you're sort of like doing authentication and then changing around the claims in a JWT and signing it and sending it back. I think the thing that I'm seeing is that we need to probably start building tighter integration with protocols like this, with systems like doing some of the things that IDP does. Maybe we need to move that into our gateways so that we can remove the hop. There's other things we can do too. I mean, a big part of, I'm really enjoying seeing people flip the idea of scopes on their head more and more. There's this thing called a macaroon, where instead of a scope, you have a caveat. And so that can help in limited circumstances. The caveat doesn't increase your access like a scope does, it decreases it. And so as you pass this macaroon or whatever other sort of caveat using authentication primitive through the system, you can attach caveats to it, and that naturally sort of descopes it, which can sort of get around some of the problem of needing to evaluate this long chain of actors each time. But even then, I think there's this problem we're seeing where we need a lot of that intelligence to be living in our gateway. And I just don't think there's a way around it.
Yeah, I mean, one of the classic things in computer science is the idea of trade-offs. If you're going to give, and this is what organizations all across the world, maybe in our chat, people are having these conversations internally, wanting to provide developers the insane promises that we're seeing when it comes to agentic developments. And there are articles coming out every week from organizations like OpenAI and Anthropic and Cloudflare talking about how they're able to iterate and become so productive with AI when deployed at scale. But the trade-off of that productivity is, I think we're seeing this industry-wide, is a serious investment and extra thought needing to be taken at the protocol layer, at the proxy layer, to be able to give us the primitives. I like that word that you used, to give us the primitives to be able to do these things securely at scale. And we're going to get into one of the bigger one of those things. So you give us a little bit of a preview there, so I'll hand it back over to you. Let's talk about policy. What does policy look like at scale when it comes to AI? How is that changing at the gateway?
And it's related to what I was just saying, actually. So when we're talking about the trade-offs here and breaking some of our long-held principles, there's this idea of dumb pipes, smart endpoints, which is a sort of special case of the idea of separation of concerns, which is the idea that when you're doing networking, you should just focus on routing things and making quick decisions. But what we're seeing in AI gateways is a need for having state, for holding on to state, unfortunately, and for doing a sort of deeper inspection of our requests. Just as an example, before we get into the policy ordering problem about why state matters at every level here, when you have a request coming through, you have headers, and the next request coming through, even if you're using a streaming protocol, is going to have headers that you can use to make a decision in isolation for each request. Okay. But whenever we're doing AI-based policies, let's say we want to know the model of that's being requested from an inference provider so that we can do something model specific. Well, that's in the body of the request. And if that's streaming, we don't have the whole body. We have a portion of the body that we can accumulate, we can buffer, but it's a completely new way of approaching the way that we are trying to build our networking systems, because now we need to buffer things up to a certain level in order to build up enough context to make a routing decision. Say we don't have headers to look at on each individual request. And so I would say that right now, because we're moving from that very stateless world into a world where state is implied at every level, the thing we don't talk about, to go back to the theme of the talk, is that currently we have lots of gateways, AI gateways. We have lots of systems like guardrail systems, semantic caches, model pickers. We have all of these, systems in place that we're trying to attach to gateways, say, and we're mostly using a control plane for it that doesn't really capture the nuances of the fact that these are state and they have cross dependencies, and they look more like data pipelines than traditional policy chains in networking speak. And so, we see a lot. I see a lot of bugs on my end because we have maybe run policies out of order, because these policies need to pass information between each other. And so I was, you had talked some about this, and I know we've been thinking a lot about this, but just the problem of needing to build policy chains that look like data pipelines.
Yeah, I think, for a lot of this for me it's what's old is new again. I think we kind of sort of find the different versions of these problems that come back cyclically. Before I get too much further, though, I actually submitted a poll for the audience to chime in, and I want to know, for folks who are here at this conference, you're interested in AI, you're attending this talk, let us know, how are you deploying an AI gateway today? Do you have it running in production already? Maybe you should be up here talking instead of us and telling us how you figured this all out. But maybe you're running this in a staging environment and getting ready to get to that point. Some of you looking at the existing results, a lot of you are still evaluating whether or not an AI gateway is right for you, which AI gateway is right for you. And then maybe some people, this is not a goal from at all. So please let us know where you are in this journey. It's going to really, help us in the AI gateway working group just get a sense for how the ecosystem in general is thinking about these problems. But to go back to your point, Morgan, about data pipelines, you're absolutely right. And I think we've had similar versions of this problem before. When an application developer wants to do some A/B testing, and they've got V1 of their service running and V2 of their service running, and the gateway is doing load balancing or routing, between both of those versions. But the admin wants to continue to make sure both versions have security policy. So you can't just bind to one version of the application, you have to bind to both. That's a perfect example of where when the gateway is doing its filter logic to execute things on the network path, what you end up seeing in some cases is that if you do them out of order, you can run your security before you know exactly which final service you're going to, and end up you can do your routing and before you do your security, and you can skip that security policy by accident. And so ordering has always sort of been important. Executing filtering logic, filtering rules on a network has always needed some state. And so I think we can look to some of the solutions we've had in the past on this topic specifically. Let's bring it into an AI world first, though. Let's say I've got this inference request coming, coming to my gateway, and I want to route it to the appropriate model based on semantics, right? If it's a really super complex query or very business critical prompt, I want that to go to my best in class model. That's going to be most expensive. If it's somebody saying thank you, then maybe I want to have a semantic cache that just gives a bottled response every time. Thank you for using our software, et cetera, et cetera. Maybe I want to go to the cheap model that I'm running on-prem. That's semantic routing and semantic caching. I want to do that based on the prompt. And as Morgan said earlier, the prompt is going to be in the body of the request. So I need to do something in the body fairly early in my pipeline to know how to handle it. Maybe before I send it to any AI model, I want to run some guardrails on it, right? To make sure that I'm not sending the model anything that is PII or private or protected data or things like that. Maybe I want to censor certain pieces. That's the guardrails piece. So there's an order that a lot of these things have to be done. Because there are some guardrails that are specific to specific models. For example, some guardrails work great on Claude, or Sonnet, but don't work as great on GPT-5. GPT-5's got some guardrails that might work better than if you run them on Opus, et cetera. So if I do my guardrails before I do my routing, maybe I've applied suboptimal guardrails for my requests. And so the way that we do this policy really can impact the security posture and the correctness of our AI-driven system. How do we solve this? Well, one of the things that we've done in the past, and we've done this in the STO project, is we actually do a trade-off. We take some control away from the user. They can't say the exact final order of their policies, but we sort of group policy execution into buckets in the gateway. You've got different phases that execution might happen to. You might have like a pre-routing phase, and then you might have a phase after the route is picked where you're going to run some policies. Maybe you run certain policies after an off step. And you allow the user to be able to sequence and order their policies within the bucket, but the order of the buckets is fixed. And that shared responsibility sort of pattern helps the gateway authors, the proxy authors, to make sure you can ensure some baseline level of correctness. And it also gives users, their users continue to have some degree of control for how policies execute. So that's an approach that I'm seeing work really well in the projects I'm a part of. Istio uses that. I work with Agent Gateway Proxy, the Agent Gateway project. They take a similar approach. And so figuring out a way for the proxy to provide some baseline guarantees while still giving some control, I think that's the balance and the trade-off for making sure policy ordering remains correct in the underpinning of a production system.
Yeah, definitely. And we're spending a lot of time upstream discussing, to the point about giving the user some control, but also helping them to catch whenever things seem to be going awry. We need to capture metadata about their policies, for example, so that we can help them to enforce a good ordering. And so we're trying to figure that out upstream, like some policies apply mutations, and so like the model picker that you mentioned, the semantic router, and that's the sort of information we can formalize via a spec, and then we can have this well-known control plane where we know if we're going to mutate, we've signaled it here, and so things have to happen post-mutation, for example, a routing decision. Yes, and so we're working on the problem. We haven't yet come up with a full enumeration of all of the information that I think we need at a baseline level to absolutely enforce a solid ordering every time for people. And so, yeah, it's certainly an interesting problem space that projects like the Agent Gateway are helping with for certain, because Agent Gateway, for those of you who haven't checked it out, it helps us to write more sophisticated policies without having to call out to a third-party service, for example, which gives us more control over what the policy is doing and more visibility into how it's implemented. And so that's what I meant by we're bringing more into our gateway than we would have historically wanted to, like by literally having some of this complex policy logic living inside of the process of the proxy itself and not a call out to some external service.
Shameless plug. We're, as Morgan mentioned, in Working Group AI Gateway, we are trying to design APIs and design standards for how this can be done for gateways. I shared a link in the chat to the AI Gateway Working Group GitHub. Please go there and chime in with your use cases for payload processing, things that need to access the body. Let us know, like we've started with some direction. We're sketching out some ideas. Take a look at what we've got and see if it's going to work for you. Let us know if there are use cases for you that are critical for you or not considering. We'd love to get more eyes on what we're doing here so we can make this a standard that's actually useful for people. And user feedback is better than the things that we can come up with. So please check it out if you would like.
Yeah, that would be great. We would love more folks coming in and bringing their use cases to us. We're building prototypes where we're exploring stuff like what goes wrong if you have policies that interact in this sort of negative way that we described. Yeah.
I want to pop in right quick, and I see a comment from Michael. Really appreciate it. Appreciate you asking this. Basically asking, is this a new problem? If you've got static set permissions at the beginning of the request, can you keep those? The problem only enters where you need to elevate permissions, sort of like a just-in-time permission elevation for the user or the bot requests. And Michael, that's exactly the problem that we're running into. When I'm working in VS Code and I'm needing to act as a certain MCP tool, the code harness, the agent harness will stop me and say, Keith, please say yes to allow this tool call. Please say yes to provide this credential. The MCP specification actually has, I want to say it's called an elicitation. This idea that while you're in the flow of requesting, like calling an MCP tool or getting a certain prompt, you might have to sign into a third-party provider for OIDC or things like that in the middle of that request. And so we are seeing the need to explicitly upscope the permissions temporarily to be able to fulfill a particular request. But something Morgan talked about earlier, though, is by default, what we want to do as administrators is downscope the permissions for agents so that the agent, if your VP is using an agent for something and they've got like authority to like all the systems, you don't want that agent to have access to everything the user does. And so this is another one of those things where we kind of are wanting to build systems that can extend permissions in both ways, upscope when needed, just in time for a temporary action, but by default downscope the permissions so that we're not having to give the agent all the permissions that the human does, because ultimately humans are responsible, they're liable, agents and AIs are not. So that's sort of how we're thinking about it. We appreciate that question. Morgan, anything to add there?
Yeah, so it's not a new problem, that's for sure. RFC 8693, which is the token exchange, defines like the actor semantics that we're using to track these chains of interactions. That predates people thinking about agentic systems like we do today, because this is a problem that already existed. I would just say that it's now a bigger problem than it used to be, because to Keith's point, there's two aspects to this. One, we might need to modify the level of access, dynamically. After all, agentic systems, the whole reason we're excited about them is because they are adaptable. They're adaptable because we don't really know what they're going to do before they do it. So we just give them tools to work with. In some cases, we let them build their own tools live. And then let them try to solve problems for us. And so I would say there, even if you don't have some sort of mechanism of sort of temporarily upping permissions like you do whenever you have an agentic loop where you have a human that can say, okay, you're allowed to do this. We also now have the problem of this Cartesian explosion of possible paths through our system. And so my argument would be that even if you think there's no way even if there's no way in your system for permissions of actors to be elevated dynamically, you still, in most cases with agentic systems, may have chains of subagent requests, potentially, if you want to build a workflow that is highly flexible, you might have chains of delegated requests that are unpredictable beforehand. And I think it's almost easier. Well, it is easier to maintain a running list of all of the actors in that chain and then evaluate, that chain and say something like, I noticed that the lowest possible permission in this chain is this, and therefore I won't let any actor in this chain associated with this request access some resource. And so it's almost easier to just create that audit trail and store it somewhere and then evaluate that audit trail via a policy engine of some kind is the way that I've been experimenting with, than to try to game out ahead of time all of the possible interactions that could happen in your system. And of course, this is something that you won't see until you start trying to build a system that can, delegate to a sub-agent. But I think the reason I liked showing that VS Code issue, even though it's not exactly permissions related, it's more billing related, is that it sort of shows that even when you just have one sub-agent, it can be really tricky to keep track of that interaction.
We're coming in. This has been a really great fireside chat. There are a number of questions for you. If you could hang out and answer those questions in the chat, we would really appreciate it.
Absolutely.
Thank you so much for this.
That was awesome. That was amazing. Thank you so much to both of you. So we're going to everybody give them a round of applause. That was incredible information. Everybody, as in everybody in the chat. Thank you. We love to see the love. Thank you.